So generally it's a squared plus bx plus c equals 0. Let's say this term's not there. Then you just have this. It's still a quadratic equation, it's just missing that middle term. Same way, you could also have something like this. You have your variable plus something, all of that squared, equal to something. This is still an indicator that your variable is squared. So it's still a quadratic equation. And in both of these cases, you can use what's known as the square root property. Okay, so what does the square root property say? Well, if you have something squared, then there's two possible solutions. Either you're going to have the positive square root or the negative square root. Why is that? Well, let's say, just imagine this way. 2 times 2 is equal to 4. Negative 2 times negative 2 is also equal to 4. So an easy way to remind yourself of why you have both a positive solution and a negative solution is that if x squared is equal to 4, I don't really have any indication whether x is a positive number or a negative number. Because if x is positive, then this is true. X should be 2, because 2 times 2 gives me 4. But if x is negative, this would also be true, because negative 2 times negative 2 equals 4. So I have two possible solutions for x. X can either equal 2 or negative 2. So when you take the square root, you actually have a plus and a minus. For this particular reason, because if your sign is unknown, if there's no other special details in the problem that tells you that your variable is positive or negative, then you have two possibilities. So now we're going to use this to solve equations. All right, so let's look at this example. We have 3x squared minus 15 equals 0. Well, the first thing I'd have to do is I need to isolate the term x squared. I have to have the x squared term completely on its own. So I could start off by moving this negative 15. Give me 3x squared equal to positive 15. So you're just adding 15 on both sides. Next, I need to get rid of this 3 coefficient of x. Well, the way to do that is I divide it out. So I get x squared is equal to 5. Okay, now finally I can get rid of the exponent. So to get rid of that exponent, I'm going to take square root. But because I'm taking square root of this unknown variable x, I have two possibilities, a positive and a negative square root. So this means that x is either positive square root of 5, negative square root of 5. I would keep my answer in the square root radical form because I want exact answers. Since 5 is not perfect squared, I cannot get an exact answer to this. If you typed it into your calculator, if you did square root of 5, it's approximately 2.23 something, something, something. That's not an exact answer. If you have a decimal, that's not an exact answer. You want only change it if it's a perfect square. If not, just keep it with the square root. Okay, now what if we have this? This is a situation where you already have your squared term completely isolated because this whole thing is being squared. So unlike the other problem where you're trying to get x squared on its own, this already has the squared term completely on its own. So we need to get rid of the exponent before we do any other operations. So the way we do that is we're going to take square root at the first step. And remember, this x has an unknown sign, so I'm going to have plus and minus. So this gives me x minus 2, and the square root is going to get rid of this square. And I get plus minus over square root of 6. So I'm going to write this as two separate equations. I have x minus 2 equal to square root of 6. I'm going to have x minus 2 equal negative square root of 6. Well, Now, how do I find x? I just add 2 on both sides. So this tells me I have 2 solutions for x. Square root of 6 plus 2. Notice the plus 2 is outside of the square root. It's not going to go inside. And then we have negative square root of 6 plus 2. And again, I'll keep my answer like that rather than changing it to a decimal, because square root of 6 is not a perfect square. So I want exact answer. I just keep it square root of 6. Okay,